All right. Bam. All right. So last we left off, we ended in a state where we can detect a rule with multiple subjects. Rock and Baba is push. And our engine does in fact detect that we have Rock and Baba is push. So what we need to do now is we need to find the rules that have these multiple subjects, and we need to break them into separate rules. So that is here. Why did I comment this? Split rules that have multiple subjects. This will just make it easier to calculate things later. Actually, you know what? I probably don't need to do that. Let's do it anyway. Alright, for I equals 0, I less than rules dot size I plus plus. If rules dot get subject, if rules dot get I dot get subject, that is not a string. It's returning the first one. Okay, I've broken something. That should be a list. Okay. Dot get subjects. Size greater than 1. Split into separate rules, which I just put up there. Yeah. What's he complaining about? Alright. Rule. How many rules will I need? Equals new rule array, and the size is going to be this guy. Alright. We're going to iterate through this guy, which I can probably extract out a little bit. So we're just going to copy our original rule. Oops. We'll send in the new one. So that will copy over pretty much everything. It will copy the subject, but we don't care about that. Yep, okay. And then r.subject. I have to do set. Oh. I'll have to add this method. So we're going to be rule dot get subjects dot get j subjects.clear. What? Oh, subject.clear. And then subject, come on, add. It's called string get. Oh, come on, guys. Okay. Oh, but the first thing we're going to do is we're going to remove it from the list. Remove I. I minus minus. And then for each one we add, do an I plus plus. Just so that we don't mess up our array. Alright, so now wait, I didn't need this. Alright. So now after we have the full list of rules, each rule should only have one subject. Uh-oh. Something went wrong. Iterate through rules.size. We've only got one rule. Right? Our rule, Rock and Baba is push. We do have multiple subjects. We're going to remove this rule from the list. So now rules should be empty. Yep. And for each subject, we're going to create a new rule. We're going to set the... Oh, no, that's right. So our new rule... Wait, what? Subject is false. Oh, rock. I was looking at the wrong thing. So we have rock is push. Add it to our list of rules. Then there's a second subject. What? What happened? Why did it do that? Try again. There should be two subjects in there. We've got two subjects. Yeah. Create a new rule. This didn't break, did it? It's still got two. We're going to get the first subject, put it on this rule, the new one we just made. Add it to our list. We've got J++ happening. So J is going to become 1. This evaluates to 1. Why is that 1? This should be 2. Why is this 1? Do these share the array? Oh, crap. They share the array. Alright, so then I need to... new array list. And then or I can just do this. Okay, that should fix that issue. Well, I have two rules, but they're not printing. Are they not marked as complete, I bet? Or true. Because when I clone them, I don't set completion. Okay, so I have Baba as push, Rock as push. Let me actually fix that utility method to the to do sb.delete char at. I want to delete two characters. sb dot last index of comma space and delete two characters. Right? That's how that works. And extends to the character. Oh, all right. All right. It's minor improvement on our debugging tool. All right. So debug is push, or debug is push. Baba is push, Rock is push. And I can close this other one. Yep, that's exactly what we want. Okay, time to test other sentences. I can get rid of all this now. So, yeah, let's put these four back in. I should get, let's see if we get all the rules we expect. Okay, so we have wall is Baba is shift. Oh, that sucks. Baba is you, Rock is push, Baba is push, Rock is float, Rock is open. So if I have something is something is something, I'm getting messed up. That's the only thing that we haven't accounted for. Alright. So let's find out why. So if I have, we have a subject, and we have another subject. It's a transformative rule. Alright, so we have a subject, we have a predicate. This is why I don't like state machines, they get pretty complicated. Alright. So we're actually going to jump into... Wait, what? If we have like rock is... What was it? Rock is... Wall is Baba is shift. Okay. So we have a subject, we have a predicate, we have a trait. If tile... If we're... Oh, wait. No, I want, if that's a predicate word. Because it could be has or make also. So, new rule! So, this rule will be completed. It was already completed, we've already added it. So, rule equals new rule. We don't need to copy this. Rule dot set subject is going to be this rule's trait. That rule is valid. Return rule. Okay, let's see. I don't think I missed anything, but testing is always free. Oh, subject is null. Actually, you know what? I'm going to handle that in here. Or I can just create a new one every time. Takes up the same amount of memory anyway. Okay, we have wall is Baba, but we didn't get Baba is shift. Why not? Oh, because on the new rule I also have to add the predicate. Set predicate will be tile.getName. There it is. Wall is Baba, Baba is shift. Alright, so I think our word parsing is working now. The only thing I haven't tested is not. That's gonna suck. Alright. Let me split these rules up. Or actually, now that we know these all work, those are going to be unit tests later, just to make sure. Alright, so now I want to do not Baba is push, and I want to do Baba is not you. Yep. Uh-oh. Did I mess something up? Level was too small. Yes, I've got Baba is push, and Baba is not you. Alright, so the not, if the first thing that I hit is not, subject inverted is true. Oh. Poor fix. Okay. So that works. So I can probably have Baba is wall is not you. So I should get Baba is wall and wall is not you. Yes. Alright, I think our rule figuring outer mobile is working. So now, what's the next step? Now the next step is control things that are you. So when we're recalculating the rules, which happens in here, so after we get our whole list of rules, we're printing them out. And then the equals method is just going to be the string version. Wait, hash sets use hash code, don't they? It's an int. All right. Okay, so now our hash set works, theoretically. Wait, what? Oh, that's not a string. That's going to be a rule. Okay. So all the rules will be unique down here. Just make sure I've got everything working. Yep. All right. We are parsing rules properly, and I think that I have tested all of the different permutations that I need to. All right. So now, let me see what my loop looks like. So this will handle when the player moves and when the player pushes or pulls something. This will be for move operations. Actually, player move should include the move word as well. Other rules would apply to things like, oh, we want to do transformation rules. I might move these to the level class. They don't really belong here. So the first rule I want to implement is you. All right. So we've recalculated the rules. At the very end of this method, this very, very long method, we're going to apply new rules. Actually, no, we're not going to do that yet, are we? Let me think. So there's a problem, and that is, I didn't mean to bring that up, but I guess it'll work. We have to be very careful what order we apply things in. Because, for example, if we do push first, and we do it for any direction, let me think about that. We can't just do it blindly on the same game space. We actually have to like clone the entire level. All the tiles anyway. We have to clone them all, have like a sandbox where all of the updates are made in the sandbox. Alright, there's something I need to test. Where's my shift? Belt is shift. Then I want some belts. Where's belt on this thing? And I want key to be push today. Where's push? There's pull. Why can't I see push? Oh, it's right next to pull. Okay. Key is push. Yeah, we have to be very careful about the order that we do things in because if I move right here, what do I expect to happen? I think both of them will move right 2 spaces. So Baba will be here and Key will be here. Okay, my assumption was correct. Turn this grid off. Are there any other experiments I want to do while I'm in here? So if I push this thing on, I can't catch up with it, right? Yeah. Alright, so I pressed up here, so it did my move, and then it did the belt move. Alright. Okay. So when I'm updating all of the tiles to give them new properties, like whether they're push or whatever. Oh, okay, that's what I wanted to test. So if I have belt is shift, so the question I want to ask is when I create a new rule, let me think about this. I think new rules are the last thing that are calculated. Yeah. So here's something interesting you can do. Baba is flag. Flag is Baba. And then Baba and flag is you. And so Baba will go back and forth between being a flag. And I'm pretty sure that whoops, wrong window. So as I move around, I just flip-flop between the two. And if I want more of myself, I can just do this. What if I want more Babas? Can't stop me. Oh, now they're like back and forth between each other. So now I've got like 10 flags and 10 Babas on the same space, and they just flip back and forth. Yeah, that's weird. Okay. So let me make sure my game loop is correct. So I'm going to do the player move as well as pushes. I think I should do pushes first, right? Oh, that's what I wanted to test before. So if I have belt as shift, and I have key as push, I've got my key there. I need to get the key on the belt. Oops. Now I have to launch the game again. I'm pretty sure push happens before shift. So I'm going to move this key. Then I'm going to kind of race it up here. Yeah, push happened first, and then shift happened after. So move and push happen at the same time. And then shift happens. And I guess all the other movement things not related to the player will happen too. Okay. So apply other moves. Apply transformation rules, and then recalculate all the rules from the new text configurations. Alright. Wait, I should apply the transformations after calculating the... Wait. Yeah, I want to do this. Right, because as soon as you push a rule like flag is wall, as soon as you create that rule, the flags change to wall on the same frame. So it has to recalculate that rule and then apply it. So this is the right order. Alright, so now I have a full list of rules. And keep my debug things in here for later. Actually, that one's useful. I'll keep that one. Although I could just have it on the screen too. All right. Yeah, apply rules. So what this method is going to do is it's going to loop through every rule that we have, and then it's going to loop through every tile on the map, and it's going to figure out what tiles have what traits. Oh, one thing we want to do though is, well, we don't really need to sort it. If we wanted to make this like super optimized, we could sort rule first and then like bucket all the different items on the map, but that's, even though it would be faster, it would not be faster to program, so I'm not going to do it. Again, I wanted to see how much I could get in one day, and I might continue this tomorrow. So for each rule, we're going to loop through. Um, when I apply these rules, do I need to know... Yeah, these are not movement rules. These are just deciding the traits of things. I will need to know the positions if I were implementing the facing keyword, but I'm not implementing the facing keyword for this engine, so I don't really care what position they're in. It's not going to let me do that. All right. Okay. Okay. If R applies to tile, then R dot apply. Okay. Seems simple enough. So applies to we'll put right here. All right, so basically the subject of this rule has to be, okay, there's a few cases, but if tile.get, actually if tile is word and subject equals text, return true. Otherwise, I think there's only really one case. We're looking at, oh, it's not going to be, it's going to be subject.getZero, right? All these rules will only have one subject. Subject get 0. Right? So there is a keyword text, so you can say things like wall is text. oh no, sorry, subject. So you could say text is float or um, text is wall, right? So you'd be able to apply this rule to, there's nothing, there's a tile called text, but you actually want to apply it to all of the words. So that's what this exception's for. Otherwise, we just look that the name of the text matches the name of the object, but with the objects just have an O in front of them. So like in here, for example, so O door is the door object, but door is just the word door. So I think that's fine, and then public boolean apply. There is one thing I did not do though. Oh, this is a void. And that is if I have a positive rule and a not rule, I need to process the nots last. Oh. What's the... Okay, the trait. I guess I can use a switch. So defeat, facing, float. I could use reflection to do this, but that would be kind of... that wouldn't really save any time. Yeah. So this is defeat. How many traits are there? Oh, they're all right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Not set facing. Open. Push, shift, shut. Stop weak win word U. Word? Oh. No, word is... I missed one. That's not actually right. Open. Push. Shift. Shut. Stop. Weak. That one's not right. Oh, I think I missed move. What? Oh, did I miss it? Oh. Alright. So if it's a transformation one, if there's a subject in the last word slot or whatever, then this won't do anything, but when we run this method right after it, that's when those are going to happen. Okay. So the next thing I want to do is the player move. When I do this, next input changes. Okay. Switch, next input. Probably don't need a switch here. It's going to be up, down, left, or right. Okay. All right. All right. We're going to make this very, very stupid. Okay. All we're going to do is make the player move. We're not going to implement stop or push or anything. We just want incremental progress, right? So level dot. So it's at times like this I wish that Java had selections. Because in JavaScript this would be like one line of code. Or really, most scripting languages, this would be one line of code. Get objects where and I want to pass new tile criteria. Create a new interface. Tile criteria. I'm basically just going to select every tile that's you and then move them all at once. Yeah, okay. Public list tile. What did I call this method? I can call it anything. I didn't call it anything yet. Alright, so list of tiles. That's going to be select. Oh, I don't define it. Doy. Okay. It's not going to let me use lambdas for this. Give me a lambda. Nope. Okay. Return. Oh, select takes a tile. Oh, crap. Let's call it matches. Is you. Oh shit, no, that's a. What am I doing? Okay. Nope, that's the wrong class. I want here. Right, public list of tiles. Get tiles where tile, what did I call it? Criteria. Yeah, let's make it a linked list. Alright. Oh geez, I have to loop through all of them. Do I have a link to all of them? Nope. I'll have to iterate through the grid. look at how nested this loop is. Oh crap, I didn't mean to do that. Okay, we'll start small. Get object, is it get tiles where? Alright. Yeah, that's fine. Okay, tile. Okay. It will soon become apparent while I'm using a number for this. 2 equals down, 4 equals left. These are just the numpad directions. Alright, so if location dot, well, let's do a switch first. We're going to do if direction equal 2, we're going to move down. But we're only going to move down if we are not at the bottom, whatever. Oh boy. This is going to have to, like, be able to ask the rest of the game where other tiles are. Okay, that's what we're going to have to do to implement, like, push and stop. For now, let's just do the move. All right. So location dot y equals if location dot y greater than 0, location dot y minus minus. Same thing for up. If location y less than, did I put that on level? Max rows plus plus. So we need 4 and 6. So if x is, this is to move left, yes. And then this is to move right. This will be max columns. And I think the sprite will automatically change its position. It won't animate or anything, it'll just kind of jump there. Oh, I have nothing on the map. Doi. So what I want is, I want Baba in some random place. Then I want Baba is you. Oops, I put the word Baba instead of the object. That's oh Baba. It's an Irish sheep. Okay, moving doesn't work, but it is running into an infinite loop calculating these rules. Okay, why is it doing that? This is why. Okay. Also, I'm going to limit my frame rate so my graphics card doesn't fucking fry itself. So why isn't anything moving? Baba should be moving. Debug it. I only implemented move up. Up doesn't work either. Okay. Tiles has nothing in it. Alright. Oh, duh. Wait, didn't I just do this? This should be true for one of them, so I should get a breakpoint here. No? Okay, my rules aren't being applied. So recalculate rules. Apply rules. I bet this is what's failing. Uh-oh. That's not what's failing. I'm gonna have to step through the whole thing. So I have Baba is you as a rule, and it recognizes it. Okay. To make debugging easier, we're going to put Baba in the bottom left corner, because that's the first one that gets processed. And we'll just put a breakpoint here. Uh-oh. I didn't debug, did I? Oh, crap. Okay, well, I hit a button and now it's doing something. Actually, what I can do is I can just look at the grid. Oh, there it is. Right, this grid 0, 0 has Baba on it. Yep, that's the one that's got Baba. That's false. So what's criteria? Oh, it's not going to give me the code, right? Criteria is defined in here. It is going to try to run this, but it's saying that that is not Baba. So my rule did not get applied. So it looks like finding Baba works. Something in here, this isn't working. Hold on, something's wrong. Get out of there. When I load the map, I'm recalculating rules when the map starts. So it should do all this, and it does. It's printing out Baba is you right here, so it should be jumping in here. This should be the first thing it does. Why is it not doing anything? It's definitely running this. There's no return in here, is there? That's causing it to break. We are getting into here, right? Okay, we're getting into all rules. Oh, that's a different array. Alright, so, oh my god, I have so many breakpoints now. So my problem is, what? Oh, that's a set. I don't think this will break anything. Alright. Oh Baba. Next. Alright, it does apply to Oh Baba. Our Baba is you rule. So now we're going to apply it. Yep. Oh, one thing I need to do is I need to clear all the rules every frame. Oh, geez. Alright, whatever. Let's see if I can move up. That should be true. There should be one tile in there. 18 tiles that the game thinks apply to... Wait, what? Why do I have so many Obabas? Oh god, what have I done? Something went wrong. Oh, I know what went wrong. Wait a minute. Oh, this should be row. Alright, there we go. Oh, I can move up. Alright, so let's implement down, left, right are going to be pretty much the same thing. It's just a different number that goes in here. So that's down, left is 4, right is 6. And then I need to handle that here, which I already did. So I should be able to move now. Okay, I can move around. Alright. That's a lot of duplicate code. I don't really like that. Okay, that's better. Test it. Okay, I can't push text yet, so I'm just walking over it. So when we recalculate rules, there's something we have to do that's very important first. Is we have to clear the rules on all existing things. Oh my god. All I really need is the shell of this loop. Reset rules. Alright, space, list tiles equal space dot tiles. Alright, for tile t in tiles, t dot set u false, set defeat false, set float false, set move false, open push shift win. What else is there? Shut stop weak. Oh. Oh, that's probably all I need for now. Okay, so we reset every tile so that it has nothing. Oh, hold on. We need to add some default rules. We always want text to be push. And are there any other built-in rules to the game? Text is always push even if it's not on screen. I think there are a couple others, but I can't remember what they are. Text is push is the only one we really need. Alright. Alright. Okay. The next step is each tile needs to know from the level what tiles are around it. So that when we try to move or push a tile, we can't move or push it into something that is stop. Okay. So how do I want to do that? I really don't want to put levels into the global object. Can I like make this a singleton? You're only ever on one level. Yeah, I guess I could do that. I don't even need to do that. When I do the get tile, get space, I can just make this static. What are you complaining about? Instance is static. Oh, pff. And then we can add some utility things like, oh, here we go. Space. Public Boolean is stop. So all right. Let's see. Spaces are stop, but tiles, you can push some tiles but not all tiles off of a space. So to determine if something can be pushed in a direction, I need to check each tile itself. Okay, so well, I'll leave that there. That works. I may not use it, but what I want to do... Oh, forgot about that. Here's what I want to do. Okay. Boolean. Void push the thing that's going to make this a little complicated is you can push chains of things. So if I've got, you know, multiple keys, if I've got multiple keys, then I can do this, right? But if something is stop, like the wall, I get all these keys up here. Right, it'll let me push up until the first one becomes stopped, right? So I have to like figure out this chain of whether a chain of pushes is allowed. Oh, so actually what we have is x and y and the direction. So okay. So first of all, if this space is stop, we're done. Okay, no problem. So now we want to get the space that is to the direction Alright, watch this math magic. Other x equals, let's see, so if it's 4 or 6, So 0, I want -1, 0, +1 equals direction -5. Well, I'm going to do -5 in the end. Wait, maybe no, I won't. I want direction mod 3, 0, 1, 2, 0, 1, 2, 0, 1, 2, -1. Or that's actually going to be x plus that. So if direction is 2, 2 mod 3 is 2, 2 minus 1, oh crap, wait, hold on. Do I want direction, I want direction -1 mod 3. Right? Or direction +2, same thing. Alright, so if direction is 2, that's going to be 1. 1 mod 3 is 1, 1 minus 1 is 0. Okay. And same thing for 8. 8 minus 1 is 7. 7 mod 3 is 1. 1 minus 1 is 0. So if I put 4 in there, that's going to be 3 mod 3, which is 0. Yeah, this will work. Okay. And then int other y equals y plus something similar. So I want 2 and 8 to matter. So this is going to be direction -1 divided by 3 -1. So 2 minus 1 is 1. 1 divided by 3 is 0. -1. Okay, so I just want 4 and 6 to come out 0. So 4 minus 1 divided by 3 is 1. 6 minus 1 divided by 3 is 1. Okay, and then 8 minus 1 is 7. Divided by 3 is 2. Yep, that's good. All right. Equals get space. Now this could be out of bounds. I don't know how I want to handle that. What I could do is if I return an out of bounds space, I can put a tile on there that is always stop and has no other properties, right? Can I do that? What are my properties again? Stop. Yeah. I'll just make a tile that is stop and nothing else. So if row less than 0 or column less than 0 or row greater than max rows greater than or equal to, or column greater than or equal to max columns, space s equals new space s dot add tile, new tile. Now I'll make that separate. Tile dot set stop So if I try to get an out of bounds space, I get a valid space that's always stop. So you can't go out of bounds. And there's nothing you could ever push out of bounds. Unless I decide to implement float, in which case I'll have to make this a little more robust. Alright, here's what else I'm going to do. I'm going to modify this guy. wall is stop, rock is push. Then I'm going to have wall, 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 rock. So they should already get the correct rules. Oh. I keep forgetting that. Okay, I can go through wall because I haven't implemented stop yet. Oh wait, yeah I have. Why can I do this? I shouldn't be able to do that. Oh, I haven't accounted for stop in here. I just did out of bounds. Okay. So it's going to be location dot. Actually, this logic that's over here. This guy. I should probably put this somewhere else. That's going to return a point. Oh. All right. So location offset by direction. Cool. I need to do the same thing, but for points. Okay. Let me just store this. Then I don't need to check the direction at all. So what I need to do is if destination is stop, or if the destination is, yeah. I don't know if I want to put any code there or not. Location.x equals p, location.y equals p.y. Okay, so now the stop rule should work, I think. It does not. But I still can't go out of bounds, so that's good. So it looks like the stop is just not on these walls. And obviously push doesn't work yet. Oh, and also, This is so that the sprite changes direction. So, what happened here? I'll have to debug this. Okay, so when I press right from here, I want to see what happens in here. Alright, destination. We've got some... Oh, there are no tiles in my destination. Why not? I'm at 1-4. That's correct. And I'm trying to go to 2-4, which is correct. Okay. This should exist. Come on. Uh-oh. Okay, I have to get there somewhere else. Where's my debug thing? Alright. What? Are they flipped? Are my coordinates flipped? Oops. Let me turn that off for now. If I try to keep going up, does this thing actually think the walls are up there? Nope, I can go all the way up. I can also go off screen. So I can't go off screen to the left. Oh. Wait, what? That's the edge of the screen. Oh. That's supposed to go up to 24. Oh, I bet this goes up to 24 and it's not supposed to. Okay, so my max rows and max columns got swapped somewhere. Let's fix that now. Max rows is 18. Max columns is 24. Oh, because I'm treating this like XY, but it's actually YX. So it should be like this. Oh, I think stop works. Aw, snap! Okay, stop works. Okay, so out of bounds down there. Okay, it's keeping me on the screen. We've implemented the stop keyword. Now we can implement push, and then we're 90% there. The only problem is, though, is I haven't sandboxed any of these updates to where tiles are, so weird things might happen. I'm going to have to clone the game state every time the player does something, do everything in the sandbox, and then copy the sandbox to the actual game. Otherwise, I might have some situations where because of the way that the looping is working, we're not actually updating things parallel, right? It's just doing one tile at a time. So there may be a case where one of these is pushing a tile. Actually, if you can only move in one direction, would that ever be an issue? I have an idea. What if Baba is push, and I've got two Babas next to each other? Does one Baba push the other, or do they move before push is happening? I Okay, they don't push each other. See, that's the problem, is that if I did this all in one loop without sandboxing, one Baba might push the other one, and then the other one might move. So he would move two spaces instead of one, the Baba in front. So I think I may, let's see. Right, what if, yeah, Baba is push, and, stop? So let's copy all these up here so I can break the sentences if I want. Oh, I have animations off. Yeah, so if they're push, so if they're just push, oh crap. Okay, yeah, so push acts like stop when there's a stop in front of them. So they won't like collapse into each other. Yep. I need to sandbox the entire level. Oh god. Really, I just need to sandbox this. I don't really care about the other stuff. The other thing, though, is when I do sprite transitions. So in the game, you can create and destroy tiles sometimes, so I haven't really accounted for that yet. So, let's try to get the push rule implemented by the end of the day, and I think that that would be a good amount of progress. Space sandbox. Okay. I bet I can just JSON this. Do I have JSON available? I don't know. Oh, sweet. Where does it come from? I guess it's just included in the SDK. That's nice. I don't want to do it here, though. Reset rules, recalculate rules. Doesn't go there. Apply rules. Alright, so when I do player move... Oh, God. I could sandbox it, but then keeping track of all the sprites and what they're connected to would be a nightmare. How do I want to do that? Oh, it's not changing direction. Oh, I got into the other playlist. Should be doing this. Did I not account for that in my... Oh. I forgot to remove that. Now Baba looks in the right direction. Yeah. Okay, so how do I want to do move and push updates so that when I'm partially looping through stuff, I don't ruin everything? Is it safe to not sandbox? If I do move first, I have to do move and push at the same time, I think. I have to do move. Oh, geez. Alright, I have to implement move the things that are you. Then push the things that are not you. I will have known which objects moved. There's no way that anything can move in separate... Oh yeah, there are. The move command can do it. Balls. I might have to sleep on this one. See, I could sandbox the entire game state. Baba's U is actually not that much memory. But the problem is, all the sprites that I have will have to point to the new versions in the sandbox. And that would be a nightmare algorithm. I'd basically... How would I even do that? I'd loop through all the sprites. Oh my god. Tiles don't know about their sprites, right? Sprites know about the tiles. Yeah. So when I copy all these tiles, I'd have to point the sprites to the copies of the tiles in the sandbox. Then, once all the updates are done, I would say grid equals sandbox, and everything would be fine again. But that in that interim, oh, that would be a nightmare. That would be so messy. I really want to implement push, but I don't know if I can finish all of that tonight. Oh boy, what do I want to do? Is there anything else I can do without implementing push? I could implement win, but that's pretty trivial. Here's something I can do before I get off tonight. Not here. When I'm calculating the rules, I want to sort the rules. Are hashed sets ordered? What the hell? Shit. Is this ordered? Yes, it is. What? It says it implements list, doesn't it? Oh, that's linked list. I don't want that. Linked hash set. Implements set clonable. Okay, it's not actually a list. But it has the linked list implementation. It's binary. It does implement collection, but not set. Oh boy. I may have to make this a list. Alright, if t dot is negated, that's the first one, I want all of the negations to go last, so they're applied last. So return, so if t is negated and t1 is not, these might give them an indeterminate order though. What I can do is, you know what, it's less expensive just for me to do a linear search. I'll just do a linear, find all the ones that are negated and throw them at the end. Or actually, I can start at the end, yeah. Equals rules dot size minus 1, I greater than equals 0, I minus minus. If rules dot get I is negated, alright, that was easy. So now the last rules should be the negative ones. Baba is you, wall is stop, ruck is push, but if I up here have wall is not stop, then I should be able to walk through walls. Yep. Although when I print them out, they're still in the wrong order. Did I sort them after the print? Yep. In just rules. So kill that. Yep. It's the last one. Wall is no longer stop. Alright, that's a good stopping point. I'm going to sleep on how to do push because it gets really complicated when you have like large chains of objects that can push each other. And when you have the move keyword, which can push things in different directions. If everything could only move in one direction each frame, it would be easy, but that's not the case in this engine, so I'll have to think about how I really want to sandbox this. So sandboxing is when you like copy the game state to like a secondary game state that the user can't see, right? And then you use this one to change this one. Like you do all your updates on this one, but you look at this one to determine what to change. So that way, like when you're looping through objects, it's possible that I could change, like let me get an example in here. Nope, wrong window. Now go away. So it's possible that I could like push one of these walls, but then something else could push it another direction. But I only want one of those things to happen each frame. But if I'm working on just a single game space, then I don't have control over the order that those things happen. So it would be indeterminate. The user would be kind of confused sometimes when things sometimes work one way and sometimes work another way. But if you sandbox it, then you guarantee that, you know, the logic is looking at this, but it's actually updating this. And then once all the updates are done, you just copy this back into here. So I think that's what I'm going to do, but I'm not going to finish that today because that's actually a lot of work. So I'm going to do it tomorrow.